Welcome to our demo presentation of workload offloading in mobile edge computing using the reliable server pooling framework. My name is Thomas Trippholz and I'm working for SimulaMed in Oslo in Norway. Before we come to the actual demo, let me shortly explain the motivation of our work, as well as a few basics around mobile edge computing, public multi-clouds, and the reliable server pooling framework. What's the motivation of our work? Well, probably all of you have such a device, smartphone. It's actually quite powerful device. It has a lot of compute power, memory, and storage, at least compared to computers a few years ago. But of course, it is also limited compared to computers of today, and particularly its battery power. So without battery power, the smartphone is actually not very smart. So what can you do if the resources on this device are not sufficient? As you can offload work into cloud systems, that is to servers in data centers, which of course has the issue of latency. In case of public multi-clouds, for example, you are in Europe and maybe the server is located in the United States or in China, but with 4G and 5G particularly, you have also the possibility of mobile edge computing. That is, you can offload work to resources nearby your phone. And of course, then this has much less latency. So the issue is, or the challenges now, of course, you have three different kinds of resources. That is resources on the user equipment itself, resources in public clouds and multi-clouds, as well as resources in mobile edge computing. So how to distribute workload efficiently? You can think about optimal strategies and think about really complex distribution approaches, for example, even applying machine learning. Well, of course, this is quite complicated. And maybe you even use more computation power to distribute your workload than to actually do the workload. So what about the other approach? Keep it as simple as possible. Well, there's been a lot of research on the complex ones. We did some thinking about the complement approach, that is, keep it simple and hopefully not too stupid. That is, our idea is to first try to combine existing simple things, that is, not to reinvent the wheel. You can think about internet standards. You have n different standards doing something slightly different than the other standards. So what about creating a new standard, combining everything? So this is quite obvious. You get n+1 standards. So this is obviously not a really nice approach, although it's of course very popular. Well, our idea is to reuse things when possible. So what we want to do is to get simple, lightweight, and efficient distribution of workload for offloading it from the user equipment. So we do not intend to have the perfect solution or a nearby optimal solution or provable optimal or such. So just a suitable solution. And what about reusing reliable server pooling, RSerPool? What is RSerPool? It's actually an IETF standard defined a little bit more than 1 decade ago in a couple of RFCs. And it provides the management of server pools, as resource pools, and the management of sessions with these pools. The servers are denoted as pool elements in the pool. And the users of the pool are called pool users. And these pools are managed by components called registrars. The two protocols, ASAP for the registration of servers into a pool and for the pool user to handle session management, and the ENRP protocol, endpoint handle space redundancy protocol, to synchronize the view of the pool among registrars. So you avoid even single points of failure to have redundancy. And it's not only a standard, it's also a nice open source implementation. For example, also provided by Ubuntu and other distributions, RSPlib. So what about we're using it for our problem, that is offloading workload from user equipment to cloud resources? Well, we have three different kinds of cloud resources. That is public multi-cloud resources, mobile edge computing resources, as well as resources on the user equipment. So what we do is to create a pool of these resources and let reliable supporting handle it. So we created for this a proof of concept setup consisting of a mobile network instantiated in form of OpenAirInterface. OpenAirInterface is an open source implementation of 4G, 5G network infrastructure, including the packet core, the enhanced packet core EPC, as well as the base station, that's inode. And since we work with open source MANO, open source management and orchestration, or shortly OSM, we want to use this for the orchestration of the resources for the EPC. So we have our own VNF of an EPC called SimulaMet OpenAirInterface EPC, which we instantiate using open source MANO in OpenStack setup at our site. And obviously, we want to do the resource pooling with RSerPool, so we use RSPlib for this. Well, instead of going into too much detail, let me now go to our actual live demo. We are using an Atos B210 as software-defined radio, and the inode B is running on a dedicated laptop computer using the OpenAirInterface inode B implementation. Our user equipment is a laptop computer attached to a USB 4G modem. This is the user interface running on the user equipment, and on the user equipment I now start a registrar as well as a pool element and the actual application as pool user. The application is the computation of fractal graphics. In the background you see Wireshark presenting the packets flowing in the setup. And in this case, now the pool user requests the computation of fractal graphics from the only pool element running directly on the user equipment. Well, this is of course not very spectacular. So I start now resources in the cloud, that is in the mobile edge computing cloud. In Oslo, in Norway, in our OpenStack cluster, I started another registrar and a third registrar in the NoNet core infrastructure as public multi-cloud. And this registrar is running in Trondheim in Norway. And of course, we need compute resources in the cloud. So therefore, I start a pool element in Tromsø in Norway, as well as another one in Gjøvik in Norway. And you see now the pool user is already requesting a new computation. And now instead of utilizing the pool element on the user equipment, it is utilizing the pool element here in the cloud, in this case in Tromsø. Now I can start two more cloud resources, a pool element in Essen in Germany, as well as a fourth pool element in Haikou in the province of Hainan in China. So now we have a public multi-cloud setup with pool elements at 4 different locations. But of course, now we want to have mobile edge computing resources. So I start a pool element in our mobile edge cloud in our OpenStack cluster in Oslo, Norway, and another one also in our OpenStack cluster. And now I trigger the computation of a new graphics. And you see it gets distributed, in this case, to the first pool element in our mobile edge computing cloud. So to make it more interesting, I reconfigure the pool user to run 9 sessions in parallel. And you see, in this case, now the resources in the mobile edge computing cloud are used instead of using the public multi-cloud. And I can start a new one. So you see, in this case, there were 4 sessions on the first pool element, 4 sessions on the second, and the 9th session, because the mobile edge computing cloud was fully loaded, was then running on a pool element in the public multi-cloud. This is quite short computation on some of these sessions. I'll start another one. And another one. So these are quite fast. Okay, now again, 4 sessions, and 1 session in the public multi-cloud. But it is what we achieve with using our setup is, if there are resources in the mobile edge computing cloud, they are preferable over resources in the public multi-cloud. And these are then, of course, also preferable over resources directly running on the user equipment. So on the user equipment, there should only be resources used for computation when we lose connectivity to the network completely, or there are no cloud resources available anymore. And as proof of concept, of course, we can say that our setup is working, so we can use the lightweight and simple reliable server pooling framework to easily distribute workload in such scenarios. And particularly, we do not have to reinvent the wheel again. So by using existing standard, of course, we can also make use of already existing tools, and particularly tool quite helpful in such scenarios here is Wireshark. And Wireshark has already dissectors for the 2 protocols of reliable server pooling, the Aggregate Server Access Protocol ASAP, which takes care of registering pool elements to a pool, and as well as handling sessions with a pool by the pool user. And the other protocol is the Endpoint Handle Space Redundancy Protocol, ENRP. And this takes care of synchronizing the view of all the pool elements among the different registrars of the setup. And particularly what I wrote as part of our work is also a nice set of statistics tools for reliable server pooling. For example, to get an overview of what is going on in the system with ASAP protocol. You can see in Wireshark nice live statistics about this. And I also wrote a dissector for Wireshark to decode the contents of the fractal generator protocol used by this nice example. And particularly to mention is everything is open source. So you can have a look at all the sources in different repositories. And particularly also, of course, feel free to make use of our software as well in your own projects. So most of these programs are licensed under GPL license. Well, to mention further is, of course, at the moment I am starting all these pool elements manually here, but as part of future work, particularly with regard to our work on virtual network functions. Of course, this is a really interesting thing to realize also using open source MANO. So with open source MANO, for example, a mobile edge computing cloud could auto-scale according to the actual workload. For example, in this case, the mobile edge computing cloud is fully loaded. So then with open source MANO and properly configure a network service, of course, there would the possibility to do auto-scaling, that is, tell the OpenStack cluster to instantiate one or more new instances, and of course to remove them if they are not really utilized. So a lot of interesting things can be done in such scenarios, and particularly, as I've said already, with a reliable RSerPooling, a simple solution for workload offloading. It's also quite easily possible to create own applications which offload their work into cloud resources in the mobile edge, as well as, if necessary, also into public clouds and public multi-clouds. This concludes our short overview of the demo. Well, if you are interested in some more details, also have a look into our publications. Particularly, we have also work on public multi-clouds, as well as reliable RSerPooling and mobile edge computing. And of course, as I've mentioned, all of our software is open source. So we are very committed in contributing to the open source community. So also have a look into our Git repositories. And maybe you can use some of these sources also for your own projects. This concludes my short demo presentation. Hope you have enjoyed our presentation. So hopefully also you can attend the live session at the IEEE LCN. And then, of course, there is more time and also the possibility to ask questions. But also, of course, you can write us an email. But wait, there is one more thing to mention. Next year, we are going to organize the M2EC 2022, which is the workshop on recent advances for multi-clouds and mobile edge computing in April next year in the beautiful city of Sydney, Australia. So if you have tried to attend the LCN last year, which was supposed to be organized in Sydney, well, maybe this is your opportunity to visit these beautiful places in Australia. So have a look at our website, where you can find a call for papers, and maybe consider submitting a paper on multi-clouds and or mobile edge computing to the M2EC 2022. So see you next year in Sydney.